Welcome back to our demonstration about how our demo applications actually work. So in the previous video I have explained briefly how the database, what the database file looks like and how it works, and what this function down here actually executes, and that it only executes once we are really connected to the database and we are able to query the database. And in this video we're going to see what the router is, what the different what the controller is, and what the models are. And we're going to implement a new route into our application. So first of all, let's again go and start our application. We can do this again. I showed it in the previous video through the terminal emulator from our computer, or you can do it from the terminal here. My preferred way is actually to just click on the npm tab and then press on the start script. And you will see down here that this is the same output that you get if you run this on a terminal. I did this in my previous video just to show that it actually is working. I'm copying this this link over here. Let me just hide these sections, open Safari, paste, enter, and this is exactly what we want to see. So our application is running, and this is the relationships that I get back from our application. So back here, now our application is running, this code is loaded into a process, and let's actually see what the lines of code, what these lines of code now do. So we have seen that at the very beginning we are requiring some files and some components of our app, and the next line of code that we want to look at is this one. We define our application, so our app, to be an express application. And later we set some variables and we add some components to it. One of the variables that we want to assign is the port number on which our application is going to be listening. And we have seen, I'm going to switch back to Safari right now, that we are listening on port 3000 here. So this is exactly what we're telling here, that if there is no port specified in the environment variables, then by default it will fall back, and that's what the end stands for here. Sorry, the or stands for here. The default fallback is the port 3000. This is also an important bit to talk about 1 second, and it's the environment variables, because here we can specify some variables, for example the port number, that might differ when we are executing our code on our production servers, for example. So it's always good practice to have these variable things, like for example the port number or the database connection string, to be environment variable friendly, or to fall back on some default values. Next thing that we're going to talk about is the router, and we see that here we create a router, and we create the router by requiring a file. I have already explained earlier that we can omit the extension here, so when we are requiring this file, we're actually requiring the file that is called router.js, because we see it here, it's router.js. And since it's good practice, let's go ahead and look what is actually contained in our file. So we fire up router.js, and we see this file is fairly short. It starts with 2 requirements, well, sorry, just 1 requirement and 1 assignation. We require express again here on top, and then we define that our router is a new express router. That's what we do in this line here, and then we can assign some routes to it, for example get requests, or we can also assign post requests, put requests, delete requests. These are the requests that I talked about in my in my video lectures. But before that, let's see here, we are actually requiring something else, and we call it the relationships controller. And this file is actually located somewhere, not right at the root of our application. It's located in the folder app that we see here on top. So let's expand that. Then we go into controllers, and then we are requiring relationships, which is this file over here. So let's double click on that and open it up. And what we see here is, again, first of all, that we are requiring something else. It's again a file, and now the 2 dots tell us that we have to look 1 folder before the folder we are in. So we are in controllers, we need to look at app, and then we want to look at models. So we open up the models, and then there should be a file which is called relationships, and in fact there is, and we're going to open up that. And now here we actually see in the entire code that there is no requirement of other files within our file tree. So we can start reading this file and from here work backwards and see how our router and how our application works. So let's get started on that. And the first line, again, we require Mongoose. And that's because we want to create a model, which is the relationships model, that is a Mongoose model. And we call this model relationships. And it has some fields that we want to specify that our model has to adhere to. So specifically, we want our objects inside the relationships database to be to have a source, to have a target, and to have a weight. The source is of type string, the target is also of type string, while the weight is of type number, which might mean we can store integer numbers or double or float numbers. All of the three fields are required, so we cannot insert elements into our database which do not adhere to this standard, to so say. So all of the objects need to have a field which is source of type string, a field which is target of type string, and a weight of type number. The last line is the module exports. This we have seen before. This is what happens when we actually require this specific file. And what we are exporting here is exactly the model. So the model that we defined over here is what we are exporting down here. And when we go back to our controllers, we see that we are requiring it here, and we are actually requiring the relationships model. So inside the relationships controller, what we are exporting is an object, and this object has an attribute which is called relationships. And this attribute actually executes a function which accepts two parameters, the first one being the request and the second one being the response. These are two parameters which are passed by, let's say, to conform to the express way of dealing with requests. So when you have an incoming request, there are some attributes which you can read off. For example, where does the request come from which IP address, who's the user, so is the user using Safari, is the user using Chrome, is the user using Firefox or something like that. And then the next one is response, and this is actually what we are gonna answer back to the user that performed the request. So let's go into this function. What we do here is we have a relationships model, the one defined over here, the one required from this file. And what we do is we want to perform a find. So we want to find the objects inside the model. And we do not just want to find a specific object, we want to find all of the objects. So we're not specifying anything more. We're just saying from our relationships model, I want to find everything. And once our relationship model returns all of the object that it contains, we want to execute a certain callback function, which is this one here, which accepts error and result. This is the type of callback function returned from the find operation. And if there is no error in finding the objects inside my database, then I want to return a response which contains our results and of status 200, which in HTTP means it was a successful request and I'm returning some results, or I'm returning what you expect me to return. On the other hand, if there was an error, so if there is an error, what I want to return is a response with a status 500, which again in HTTP means there has been an error on the server side, and I want to send my error back to the user so that the user knows or what kind of problem might have happened. So now we have seen what calling this relationships function actually does. It will answer to a certain response, will answer to a certain request with a response that is either an error or a successful response, and it would return the results of finding all of the objects in our relationships model. So we go back to the router, and we were here on this line where we actually required our relationships controller. And as I said before, in the router we can specify requests that we want to be available from a router. So for example, here we specify that if an incoming request is a GET request and it matches this URL, then we perform the the function from the relationships controller, which is called relationships, which is the function that we have just seen 1 second ago. We can also change the get to, for example, post, and this would be then a post request or a put request or a delete request, and this obviously depends on what you actually want to do. But in our specific case, what we want is we want to get data, so we want to specify a get request. And the difference between get, put, post, and delete request I have explained in my video lectures. So what we see here now is that if we navigate to this API relationships, as I said before, we're executing this function, and you might have noticed that at the end here, we're actually not calling the function, so we're not specifying one specific call of the function, but we're just specifying, let's so say, the blueprint of the function. We're specifying what needs to be called if a user is trying to open up this root. And this is because when this code gets executed for the first time, if we had something like this here, we would actually execute the function on that moment. So say today I start my server, this code gets executed after I start my server. It performs this request, and this will be stored, let's say here. And then every time someone calls this call, the same object will always be returned. So the same array of relationships will always be returned. But obviously in our database, the data might change over time. So what we want to say is every time a user is calling this request, I don't want my application to just return the result of the first time I executed the code and I executed this function, but I want to execute a function on the spot at the moment for that user, and I want to answer to that user exactly the data that we get back from the database at that specific point in that specific point in time. The last thing that we see here is that we are exporting again, because this is necessary for the other files requiring this file to know what would we actually want to achieve by requiring this file. And what I'm exporting here is exactly the router object, which is the one that we have defined over here and to which we have assigned a root, a get request over here. So now we can go back into the index.json where we actually required the router and we assigned it to this variable here. And we can say that our router is listening on the root here, and we are using the root of our application. And if an incoming request get on the root and it matches one of the router's specified incoming requests, for example, /API/relationships, as we have seen here, then you have to answer. You have to answer with this call of this function, which is what basically we're telling the application here. The last part of the code in our index.js we have already mentioned in the previous video. Basically what we do here is we actually start listening. This is the most important part. This is really where we say, now we have loaded all of our controllers, we have loaded all of our roots, we have executed all of our logic that we need to bootstrap our application, and now we actually want to start listening to incoming requests. And the way we do that is basically we say, we start listening on a port that has been specified before. So app get port will get this variable, which we have set here. And then once the server is actually listening, we execute a callback function and we print on the log that our Express server is listening on the port that we have specified and the application is running, and we should be able to connect to localhost port number /API/relationships, and we should be able to get back the data that we see here. So this is exactly the flow of our application, what we have just seen. But now what we want to do is we want to specify that we want to get we want to have a request where we're getting data, but we're only getting the relationships for the source that is, for example, Amen. So how do we do that? We go back to our web store and we start implementing a new route. So we know that the routes are defined into the router, so we don't have to modify index, but we have to modify a router first. And our routes are specified exactly here. So we can come up with any name that we want. I'm gonna delete the semicolon at the end of this line. I'm gonna copy paste this line one line below. It's another get request because we're getting data, and we want to get the relationships for the character Eamon. We obviously need to change the type of the function that we're going to call, so we want the relationships only for Eamon. And we also have to add the semicolon here because I deleted it from here before. What you can actually immediately notice is that the color of these two blueprints of the function are different, and this is because WebStorm automatically knows that in the file controllers relationships there is no key that has the name relationships Eamon defined. So if I hover over it, it actually tells me there's an unresolved variable relationships Eamon. It doesn't happen here because this is obviously defined. So what we have to do now is actually to define this this function over in the controller. So what we do is I am copy pasting the name of this function just out of simplicity. I navigate to controllers relationships. I append at the end here a comma. Then I specify my new the new function that I want to implement, a column. And I basically, I can copy what is written above here. I say function, then I put request and response. And automatically WebStorm has already put the parentheses for me. Just to be consistent with the way I have written them over here, I will delete some of the spaces. And then what we want to do here is we want to return, we want to find in our relationships model only those objects which have as a source Eamon. So we can copy what is over here because this is actually good code and there's no reason why not to reuse it. So we can just copy what we have over there. If we look at the documentation of Mongoose, we will see that in the find function of a model, we can specify as the first parameter an object. So let's put an object in. And then we put a comma and we leave the callback as it is. And in this object, I'm gonna now return just to have more space here. In this object, we can specify what filters to apply on our data before we get it out. So the filters we want to apply, as we said before, are that the source must equal Eamon. So this is all we have to do now to be sure that when we perform the find operation on our relationships model, we only filter out those elements of which the source is Eamon. The rest, as I said before, the callback is actually working pretty well because we will have a very similar result of above here that we have above here. We will have, if we have an error, then we just return there was some kind of an error, so this is the error. And if there was no error, we will have some results, which are most likely and hopefully gonna be the those elements in which the source is Eamon, and we will return these elements to the user. So now I am saving this, and as you have noticed, I have actually not needed. There's no need for me to change the model because the model is the same. There's no difference there. The only thing again that I'm changing here is just I am filtering out the relationships such that what I get is that the source of our relationships is Eamon. Now I have saved this file. I have saved this file. There's no modification here, so there's no need to save anything here. If I go back to my run tab here, I can restart the process, and this is needed because, as I just mentioned, we have modified files here. And when we start the process here, what actually happens inside your PC or inside your Mac or Linux machine is that the files that you have here, they're being collected inside a process, and the process contains a copy of the files. So since the copy is outdated, I need to restart my server, and I can do that by pressing this button. If I was using the terminal, you would have to press Ctrl+C, and then you can just type in npm start again. So just for the sake, here I press run again. the output is gonna be the same because I'm not logging anything new. But when I go to Safari now and I have my API relationships root, if I now append Amon, as you see here, what I will get is a new array. So this is the array of objects with only 2 objects, and the 2 objects that I get are with the source Amon. These are the only 2 objects that I have in my database which have this source. So we were successful in implementing this root, and we can also confirm that by going back, looking at our complete relationships root with all of our relationships data, and that you will see that at the very top there's only 2 objects which has as a source Amon, and they are exactly the same ones that we get if we navigate back to this root. So yes, this is exactly what I wanted to show you. You have seen that it's actually really easy to implement a new root. Probably you want to do this in a more systematic and a more reusable way. So instead of defining really specific names for characters, since we're dealing with a database and the names might change, you can define a variable here. So basically I can say column name, source name is even better, source name. And this way I can use this variable later inside my relationships controller to just filter out those sources, those objects of which the source is the name that I specify here. So for example, I might write ABC here, and then what this value will hold is ABC. So somewhere in the roots over here, in the controllers over here, I can, instead of hard coding in the name, I can use something like source name. There is more to that. It's actually not that easy. You have to define a couple of things here and there, but this is just to give an idea of how to make this code more reusable. This is all. Dennis is going to talk to you about the visual part of our application. In his example application, there will be also views defined inside of the code, which I am missing in this code, simply because out of simplicity, this is just an API. In the views part, even if you navigate to index.js, there will be some new lines of code which you should look into. They are interesting, and I'm fairly sure that if you understand those lines of code, you actually understand how the application works. So that is a good test for you to try out and have fun.